All right, IM3 classes. Today, we are talking about how to find rational solutions to all types of polynomial equations. So we've been looking at just specifically quadratics for the last week or so. That's a polynomial with a degree of 2. So we learned how to factor and solve, use complete the square, using quadratic formula. So right now, what we're going to do is learn how to solve equations, how to find, solve polynomial equations when the degree is bigger than 2. We're going to focus mainly on a degree of 3. Here's step-by-step directions. I'll have a printout of this in class so you can have it so you don't need to write it all down. But basically, the first step to solving a polynomial equation is to guess and check. You look at the last factor and the first factor. So possible rational roots are of the form m over n. So factor the constant term, m is the constant term, so the last number, n is the leading coefficient, so whatever on the first number. Divide those and you list them out. So this specific example, x cubed minus 11x squared plus 3x plus 5, plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. Those are all possible solutions to this equation. And so what it is, you guess and check. So it looks like only 4. It's really, there's 8 possible solutions. And so you start off guessing and checking. So here you start off, well, we'll see if 1 works, and you use synthetic division that we learned. It's really quick. So synthetic division, if you do it and there's a remainder, that means it's not a solution. If you work it out and there is no remainder, that means it is a solution. So we have 5, right? We guess and check 0. So 0 is a solution. And then once we're down to there, we know that it's x minus 5 is one of the possibilities. That's one of the solutions. So we divide it out, and then you're left with something you can factor. All right, so let's just go ahead and look at an example. We're going to find all the roots. 1 root has been given. So for the first few problems on the assignment from today, you do not have to guess and check. The root is going to be given to you. So just a reminder, the root is -3, so that means the factor is going to be x plus 3 when we get down to it. So this is going to be the factor that we know. So starting off, we are going to divide this using synthetic division. So since -3 is a solution, we know that this polynomial divides by x plus 3. But we still need to divide it out to figure out the remaining one. So I'm going to put my numbers 1, 9, 26, 24, -3 on the outside. First step is you bring down the 1, and then remember you multiply by that number on the outside. So multiply by -3, you get -3. 9 plus -3 is positive 6. Multiply by -3. You get -18. 26 plus -18 is positive 8. Then multiply by -3 one more time. You get -24, which is 0. So the remainder there is 0. So my polynomial right now, this is going to factor to the x plus 3 times these. So it's going to start one factor here. So it's going to be 1x squared plus 6x plus 8 is equal to 0. So here, so we have the x plus 3 because we divide by the -3. So remember, it is opposite. This part now, what we're going to do is factor that. So we are going to factor just the remaining, what we divided by here. So it's 8 on top, 6 on bottom, factors 8, that is 6, that's 2 and 4. So all the factors, so we have x plus 3, and then it's x plus 2, x plus 4 equal to 0. Last step, finding all the zeros. So just a reminder, you separate out all the factors. set them each equal to 0. So I'm going to subtract 3. I actually didn't need to know this one because we already did it. That was given to us. So we know that is a solution. X plus 2. So subtract 2, get x equals -2. And then subtract 4, you get x is equal to -4. All right. So let's look at another example. So again, the factor is given to us. So we're going to start off, we are going to divide that polynomial by really what we're dividing by is x plus 5 because we're going to use -5 out here. So it's 1, 5, -25, -125. Bring down the 1, multiply by -5. Get 0. So multiply by -5 is 0. You get -25. -25 times -5 is +125. So you add that, that's 0. So our remainder is 0. So the remaining factor here, it's going to be x squared plus 0x minus 25, which this all simplifies to x squared minus 25 is equal to 0. So here, now we just need to solve for x to find our last two. Just a reminder, the factor that we get from this one, I'm not going to put down in there, but it's x plus 5 is the factor that we get there. I just need to factor this. This is a difference of squares. So this factors into square of the first, plus or minus, square of the second. And so when we solve that, we get x plus 5 is equal to 0, x minus 5 is equal to 0. Subtract 5 here, you get x is equal to -5. Add 5 here, you get x is equal to +5. I should point out, so we have 3 solutions here. So -5, so we just found -5 and 5 there. And then the one given to us was -5 up there. So x is equal to -5, -5, 5. Since these match up, you don't really need to write it twice, but what we do is we say that x has a solution of -5 with a multiplicity of 2, because there's 2 of them, and then also 5. We can shorten down the multiplicity. You'll see -5 multi 2. So that means there's 2 -5s in the zeros. All right. Let's look at an example where we're going to have to guess and check to see. So we're going to find the rational zeros. So what we need to do, we need the factors of the first. This is nice because it's just 1 in front, but you're going to take the factors of the front number. All right, so n, the factors of the leading coefficient are 1, the factors of the constant term, 8. So what divides 8? Well, 1, 2, 4, and 8. And so you put all of these over 8. So it's going to be m over n could be 1 over 1, which is 1, 2 over 1, and it's all plus or minus. Plus or minus 4, plus or minus 8. So again, I'm making it's 1 over 1, 2 over 1, 4 over 1, 8 over 1. If there was something bigger here, like if it was a 2, you'd have to do 1 over 2, 2 over 2, 4 over 2, and the list can get pretty long. But we're just going to keep it simple here. Now I need to test, so I'm just going to go ahead and start with 1. Positive 1, I'm going to test to see if that divides it out. So 1, -1, -10, -8. use synthetic division real quick, bring down the 1. 1 times 1 is 1, that's 0. 0 times 1 is 0, that's negative 10 times 1 is negative 10. How do you get negative 18? Since there is a remainder, this does not work out. So positive 1 is not a solution. All right, so just down the list, I'll try, negative 1. So 1, negative 10, negative 8. I missed one. Negative 1, negative 10, negative 8. So bring down the 1. 1 times negative 1 is negative 1. That's going to be negative 2. Times negative 2 is 2. So negative 10 times plus 2 is negative 8. Times negative 1 is 8 is 0. Whew. That worked out. Good. I didn't want to guess out. So this works. All right. So that means one of our solutions is negative 1. All right. Now we need to find the other ones. All right. To find the other ones, what I'm going to do is take the remaining polynomial. So it's going to be 1 x squared minus 2x minus 8 set equal to 0 and solve that. So I'm going to factor it. So negative 8, negative 2. So that's going to be negative 4, positive 2. So the factors x minus 4 and then x minus 2 equal to 0. Set them each equal to 0. And solve so you get x is equal to 4 on this one. X is equal to positive, no, this was plus 2. So negative 2. So the 3 solutions for this polynomial, I'll write them over here. X can be negative 1, 4, negative 2. 3 solutions. Let's do one more. That is a huge number to guess and check. That's sure, why not? All right. N, the factors of the leading term are 1 and 2. The M, the factors of this number, it's going to be 1, 2, 3, and 6. So factors of 6. What divides 6 there? So M over N. I don't know why I put 2 there. So all possible zeros. So 1 over 1. So it'd be plus or minus 1 over 1, which is 1. Plus or minus 1 over 2. 1/2. Then plus or minus 2 over 1, which is 2. Plus or minus 2 over 2, which is 1. We already have that. So plus or minus 3 over 1. Plus or minus 3 over 2. And then plus or minus 6 over 1. And then plus or minus 6 over 2, which is 3. We already have that. So you just go through, list them all out, and now we test them. So 2, negative 1, negative 13, negative 6. We'll just start with positive 1. Bring down the 2. 2 times 1 is 2. Negative 1. Negative 1. No, you get positive 1. 1 times 1 is 1. You get negative 12. Times 1 is negative 12. That's negative 18. The remainder here has a remainder, so not a solution. Test out the next one. I'm going to do negative 1. So 2, negative 1, negative 13, negative 6. Bring down the 2. 2 times negative 1 is negative 2. Negative 1 times negative 2 is, or plus negative 2 is negative 3. Times negative 1 is positive 3. Negative 10, that's 10. That's negative 10 and negative 16. Again, as a remainder, not it. Just got to test out the next one. I'm going to skip the fraction. Who wants to do that? Not me. So 2. So 2, -1, -13, -6. Bring down the 2. Really hope this is it because I'm kind of tired of doing this already. So 2 times 2 is 4. Time plus -1 is 3. Times 2 is 6. Plus -13 is -7 times 2 is -14. And that comes out to -20 as a remainder right there. So not it. So let's do -2. So 2, -1, -13, -6. Bring down the 2. Times 2 times -2 is -4. -5 times -2 is +10. Plus -13 is -3 times -2 is +6. We get 0. There we go. We finally found a 0. So here it is. So now I'm going to have a factor. So 2x squared minus 5x minus 3 is equal to 0. Factor that, get -6 on top, -5 on bottom. Factors of -6 add to -5. That's going to be -6, +1. Don't forget to divide out the 2 since we multiplied by it. So that reduces to -3. So my factors are x minus 3 and 2x plus 1. Set them equal to 0 to solve. Solve this equation, add 3 to both sides, you get x is equal to +3. This one over here, subtract 1, divide by 2, you get x equal to -1/2. So skipping some steps there. So my 3 solutions, I found -2 by dividing, and then 3, then -1/2. And there we go. That is it for today. If you have questions, just let me know. Other than that, we'll see you guys all next time.